that for a Joule control test, your calculus is going to be tested. It's only two aspects: definition of a derivative from first principles and the rules of differentiation, what we are doing now. Okay, so please make sure you take this serious. Yes. That's first principle. We won't test you on limits directly. No. All right, let's start with the first question here. Now, as I told you yesterday, there are four different types of notations for the derivative. Four types of notations for the derivative. So the d of x, that's the differential operator. Okay? When you are finding the derivative using the differential operator, you don't stop writing d of x until at that moment when you decide that, okay, now I'm going to find the derivative. So here, the four terms are already simplified. By they are already simplified, I mean there are no square roots, there are no division lines, and there are no brackets. So if you don't have brackets, square roots, and division lines, then you can use the rules of differentiation. So this will be equal to, now I'm going to differentiate straight away because it's already simplified. So 13 is the exponent. So that will be 13 times the coefficient of x there, which is the 1. So you get 13x to the power of 13 minus 1. Then the next one will be 2 times minus 50. That will be minus 30x to the power of 2 minus 1. The third term, it will be plus. Now, the exponent of this x here, it's a 1. Okay? The exponent of that x there is a 1. So it will be 1 times 2, that will give you 2x to the power of 1 minus 1. The derivative of a constant is a 0. Okay? The derivative of a constant is a 0. So the final answer will be 13x to the power of 12 minus 30x to the power of 1 plus 2, because 1 minus 1 gives me 0. X to the power of 0 is a 1. 1 times 2 will give you a 2. So this will be the answer. Okay? That's the derivative there. Right, any question? Right, I just want to remind you that for you to be able to find the derivative, you have to know your exponents. If you forgot your exponents, go back to grade 11. That's why I gave you those two ebooks, Mind Action Series and Platinum Maths grade 11. Okay, you go there just to refresh yourself if you forgot a concept, like in this case. All right, so that's the first one. Then question S, okay, we have got f of x equal to 1 minus x plus 3x to the power 4. Now, all the three terms are already simplified. There are no brackets, no square roots, no division lines. So I can find my derivative. It will be f prime of x will be equal to the derivative of a constant, in this case 1 is a 0. Then the derivative of minus x. Now the coefficient, the exponent of that x is a 1. So it will be 1 times minus 1, you get minus 1. X to the power of 1 minus 1 plus 4 times 3, that's 12x. That will be x to the power of 4 minus 1. Okay? Then the final answer, x to the power of 1 minus 1 gives me x to the power of 0, which is 1 times minus 1, gives me minus 1. Then that one becomes positive, 12x to the power of 3. Right? So that's what you're supposed to get as your f prime of x. Let me carry on to the next one. Right. Question 2a. Right now, This one here, because we are multiplying a binomial in the binomial, we have to find the derivative of that product. We have to remove the brackets first using FOIL. So the next step here would be to write d of x, because I'm not finding the derivative yet. I'm just simplifying to an expression that can be differentiated. So 2x times x, that will be 2x squared, right? Then 2x times positive 4, that will be 8x. Minus 3 times x, that's minus 3x. Then minus 3 times positive 4, that's minus 12.
Yes.
Right? And this will give me d of x. I'm not finding the derivative as yet. I'm just simplifying. We get 2x squared plus 5x minus 12. Since I'm not finding the derivative as yet, I had to continue writing d of x. You only stop writing d of x when you decide that now I want to find the derivative. Okay? And this d of x is not written on the left-hand side of the equal sign, it's written on the right-hand side. Okay? Then from here now, I'm going to find my derivative. So 2 times 2, that will give me a 4x to the power of 2 minus 1. Okay? Plus, the exponent here is a 1. 1 times 5, that's a positive 5x to the power of 1 minus 1. Derivative of a constant is a 0. So the final answer will be 4x, because 2 minus 1, it's a 1. Plus x to the power of 0, that's 1 times 5, you get to 5. Right? And also, you need to be aware that the derivative of a quadratic function is a linear function. Okay? Yes?
How do you tell that 5 to 0?
Which one?
The 5. Because it's 1. Yes, good question.
Yeah, it's incorrect. If you do, that means you are now finding what is called the second derivative. Now, in this case, we are only finding the first derivative. So this derivative that we have here, d of x, that's a first derivative. When you get here, don't differentiate again. If you do that, you'll be finding the second derivative. Which in that case, it will be 4. Yes, you may lose marks, but yes, if it's the second derivative, then the question has to be specific. But generally, you are just finding the first derivative, and that's f prime of x, d of x, dy dx, y prime. Okay, all right. Any question? Any question? Let me warn you, this part that I'm doing is there in your paper. Okay? Which is there in your paper. Okay, so let's do I. Alright. Now, for you to be able to do I, first thing, remove the square root signs. But before you do that, I would suggest that you remove the square root signs first, then you use the first law of exponents by splitting the numerators under the same denominator. So this will be d of x of, that will be the same as x to the power of 2 over 3.
Yes.
Right? That would be x to the power of 2 over 3 minus x to the power of a half all over x to the power of a half. Okay? That's the first step. To remove the square root sign. You cannot find the derivative when the square root sign is there. Okay? And just to remind you, because the other class someone was asking me something that shocked me. You are in metric now. You are expected to know that the square root of x is the same as x to the power of a half.
Say, where does the half come from?
Alright. Okay, let's get on now. So from there, we write d of x. Now I'm going to write each numerator under the same denominator. So that will be d of x. I'm still simplifying. Why am I doing that? I want to eliminate this division line. Because for you to find the derivative, there mustn't be any division line. There mustn't be any square root. No brackets. Right? So this will be x to the power of 2 over 3 over x to the power of a half minus x to the power of a half over x to the power of a half. Alright, now this is not the only way of doing it. I will take out a common factor in the numerator, but that would make it very complicated, so let's do it this way. Right, then d of x. Now we have to use our knowledge of exponents now. Second law of exponents. If you are dividing bases that are the same, you subtract the exponents. Okay? So this becomes d of x to the power of 2 over 3 minus a half. Minus. Now this one here, it's very interesting because the numerator and the denominator are the same. So they cancel out and you end up having a 1.
Yes.
So we are only supposed to simplify this part here. So 2 over 3 minus a half is the same as 4 over 6 minus 3 over 6, which will give you 1 over 6. Alright? So I'm going to move on and say this is equivalent to d of x of x to the power of 1 over 6 minus 1. Now it's simplified. Now, the good thing about this is that the derivative of the constant is 0, so we just have to multiply 1 over 6 times the coefficient of x here, which is a 1. So the answer will be 1 over 6x to the power of 1 over 6 minus 1. Okay, let me write it. So it will be 1 over 6. 1 over 6 minus 1. You always subtract. You always subtract. Never think about adding. So this will be 1 over 6x to the power of negative 5 over 6. What? Look here. This is not complicated. I have told you, listen, stop talking and pay attention. Stop talking and pay attention. We don't want that square root. So we simplify to x to the power of a half. Also, we don't want this 1 over x because the x is a denominator. So we use this law or definition, x to the power of minus n is equal to 1 over x to the n. We move from the right towards the left, and I've said this many times. And you were taught that from grade 9 or 10. Okay, remember, you are in matric now. You are expected to know all the concepts from previous grades. Okay, yes. Okay, dy over dx, that's the gradient. Did you go over your derivative notations that I spoke about yesterday? Alright, so we can simplify that by using FOIL, which will be 2x to the power of a half minus x power of minus 1 times 2x to the power of a half minus x to the power of minus 1, like that. So if you multiply, use FOIL. Can you pay attention? Hey, can you pay attention? So 2x to the power of a half. 2 times 2 will give you a 4. I am not finding the derivative yet. This dy dx, that's the derivative. Okay? So I can't write dy over dx because this is not the derivative. It's still y. I'm simplifying it. Right? So x to the power of a half times x to the power of a half. If you use the first law of exponents, it means you add the what? Exponent. So half plus the half, that gives you what? 1. So you end up having 4x. Right? Then 2x to the power of a half times x to the power of minus 1. You add the exponents. So this will be minus 2x half plus minus 1, that's minus a half. Okay? Then x to the power of minus 1 times 2x to the power of a half, you get another minus 2x to the power of minus a half. Okay? Yes, a half. A half plus minus. Okay, okay, let's do this. First, you multiply those two. Then these two. Then
Half plus half is 1 after.
then these two. Foil, remember? Yeah. You remember you did foil? Yeah. So that's what you got there. So x to the power of minus 1 times, this is negative now. Negative and negative give us positive. Minus 1 plus minus 1, that will give us negative 2. Okay. Do me a favor. Today, when you go home, go over your laws of exponents. Don't go to bed without knowing, without going over your exponents. Okay? Alright. So now I'm gonna, okay, wait, before I find the derivative. These two are like terms. So I can simplify them and write y equal to 4x, that will be minus 4x to the power of a half. Okay? That will be plus x to the power of minus 2. Now that it is simplified, I can now determine the derivative. Yes?
So if the exponent minus, there's a better negative half at the top of this.
Which one?
And what's the way you do the line?
Oh yeah, this one is a negative a half.
Yeah.
So thank you for that. At least it shows that you are following what's happening. Alright, dy over dx will be equal to, now here, the exponent here is a 1. 1 times 4 is here 4x to the power of 1 minus 1. Hey, can you stop that? Then minus a half times minus 4. So we are now multiplying this minus a half by that negative 4. So we get positive 2x to the power of minus a half minus 1. Then this minus 2, this minus 2 here, it multiplies the coefficient of x, which is 1. So we get minus 2x to the power of minus 2 minus 2 minus 1. Alright, then the final answer, well, let me write it in rows of space. The final answer is going to be x to the power of 0, that's a 1, so you get 4. Then minus a half minus 1, that's minus 3 over 2, so you get 2 you get plus 2x to the power of minus 3 over 2. Minus 2x to the power of minus 2. Like that. So that will be the final answer. Okay.